Dear students, in the previous class we started the new chapter, chapter 4 Magnets and Electromagnets. In that video, we discussed about magnetism, attraction and repulsion, and magnetic fields of a magnet. We saw that various experiments show the properties of magnets and magnetic materials, but they do not explain what is happening. A theory is needed to explain the effects of magnetism and to help us use it. Today, we are going to learn about this theory known as theory of magnetism. Students, as I told before, you know that each magnet has two opposite poles, North Pole and South Pole, or no magnet exists with one pole. If you take a magnet and break it into two, new poles would appear at the cut end. The new, smaller magnet would have north and south poles just like the original magnet that you cut into half. Breaking it into smaller and smaller pieces produces smaller and smaller complete magnets. This is the theory of magnetism. By this theory, magnetic materials can be thought of as containing tiny molecular magnets. For example, inside a material like iron, the molecular magnets can line up in groups called domains. The diagram shows the molecular magnet arrangement inside an unmagnetized iron. You can notice that the domains are randomly arranged, that is, they are disordered. These domains are sensitive to magnetic fields. If you place a magnet near to an unmagnetized iron, due to the magnetic field of the magnet, the domains get rearranged. The domains will line up in an orderly way. This makes the iron into a magnet, or we can say it becomes magnetized. So, by using the theory of magnetism, we can magnetize a piece of iron. Let's see how we can do this. Magnetizing an iron nail. For this, you need an iron nail and a magnet. You can notice that the pin is not attracted to the nail. That is, nail is not a magnet now. Take the iron nail and stroke or rub repeatedly with a bar magnet in a single direction using a single face of the bar magnet. Later, bring the pin towards the nail. You can see that the nail attracts the pin. Now, the iron nail is a magnet. So, you can easily magnetize a piece of iron by stroking it repeatedly with a magnet. In the unmagnetized iron nail, the domains are not in order. When you bring a magnet nearby the iron nail and stroke repeatedly it with, the north pole of the magnet attracts the south pole of the molecular magnets of the nail. Thus, the domains are orderly arranged and nail is magnetized with proper north pole and south pole so that it can attract things. Similarly, we can demagnetize a permanent magnet by this theory. You can notice that the ring magnet attracts iron nail as well as the iron filings. That is, it is a permanent magnet. Let's see how we can demagnetize this ring magnet. Once you heat the ring magnet in a medium flame for at least 2 minutes, it will lose its magnetic property. After heating, when you bring it near the iron filings, you can notice that the magnet is not attracting the iron filings or the iron nail. Now, the ring magnet is no more a magnet. We can demagnetize a permanent magnet by heating it up and then quickly cooling it in cold water. The diagram shows what happens to the domains when this is done. You know that in the permanent magnet, the domains are orderly arranged. Once you heat it, the domains will gain energy from the heat and they will start to move faster. When they move faster, they get rearranged and they are no more orderly arranged. This makes the domain unaligned and demagnetization of the magnet. Thus, the theory of magnetism explains well about the effects of magnetism and help us to use it. Thank you.